YouTube. So today I was browsing YouTube and then this appears on my recommendation. And because why not? Just take a look at it. And boy, it is triggering. I will not play the whole video here, but I will show you the section that actually triggers. I believe it's here. It's correct so far. It's an evaporator and a condenser. Assuming it connects. Oh yeah. The evaporator is on top. He talks what thermistor. The control board, no problem with that whatsoever. The compressor. And then there's this.
On the output of the compressor, we also have this component, that is called a muffler.
Well folks, today we learn. That part is the output of the compressor, okay? Not the suction. And also that damn thing is not a suction accumulator. It's a muffler. And its purpose is to...
And this is used to reduce the buzzing and hissing noise from the compressor.
That's new. Impressive. That's new. Wow, I never knew that. So I believe I've been doing what I do wrong all this time. I thought this was a suction to prevent liquid refrigerant to going back to the compressor. So apparently I was wrong all this time. Wow. Good to know. Good to know.
On this copper tube circuit, we can also see this component here. And this is called an expansion valve.
Okay, here's the thing. That's not called an expansion valve. That's a filter dryer and a capillary tube. It's called metering device, not a TXV. TXV is its own thing. And this is either a check valve or a filter dryer inside. It varies, depends on manufacturer, especially for small units. That I've seen a lot of these things that are empty. So I can't really say it's a filter dryer or something. I mean, in some case, there are also this thing that doesn't even have anything in it. So I guess its only purpose is to make a connection. That's all.
Actually, this setup is using an expansion valve that is based on a capillary tube.
Again, metering device, not an expansion valve based on capillary tube. TXV is a metering device, as well as capillary tube.
Which is just a long copper tube with a very small internal diameter.
Okay, let's skip. If you want to check the full video, go ahead on his channel. I won't play the whole video here.
Conditioner has two main components that are
I believe it's not that one.
called radiators. One will get colder than the room temperature and the other one will get hotter.
That is also
Obviously,
correct.
by the laws of thermodynamics, the temperature always this evaporator, then we pass to the side cold and the other one hot.
Here it is.
Well, through these radiators we have some copper tubes that are closed in a loop.
Here it is.
So it's coming out from the compressor.
Wow! It comes out here. I never know that, so I've been doing it wrong all this time.
Through the evaporator, then we pass to the expansion valve, and then to the condenser, and from...
Yeah, I've been doing it wrong all this time. I never know that. That's impressive. I really appreciate him making this video because otherwise I wouldn't know better. Because I've been doing it wrong all this time.
Here we get back into the compressor and repeat. So we have a copper coil on...
Okay, in his defense, he did actually make a schematic of it on a 3D, what do you call it, 3D design or something, and it shows a correct way, like a correct flow direction right here. So I don't know why he even bothered to put that one even though it was completely wrong. I just don't get it. It's a mix. Okay.
container in order to prevent leaking and also reduce the noise. Nowadays we use a screw compressor instead of a basic piston compressor. The basic one consists of a motor.
Okay, where is that one where he showed the compressor?
Turner diameter in order to restrict the refrigerant flow.
That is correct. That's how capillary tube works. It's not variable, it's a fixed metering device. While TX3 is a, what is it? Some people call it variable. It depends on the temperature of the suction and stuff.
Flow. If the flow is restricted, like this we can separate the high pressure on one side and the low pressure on the other side.
Okay. The pressure position is actually correct. Just the filter dryer position is incorrect. You don't put a filter dryer or a check valve or whatever it is, depends on manufacturer, on the low pressure side, because that's liquid. I mean, technically both of them are liquid, but like, I've never seen someone do it this way. It's usually the other way.
But when the pressure drops, the refrigerant will turn back into a gas. Now this refrigerant is a special liquid, it's not water. It's a special substance that will boil at room temperature. A commonly used liquid is the R22 or the R290.
Wait, what? Wait, R290 in an AC? Excuse me? What is happening here? I never know anyone used R290 in an AC before. I thought it was only used in a commercial refrigeration. It's like usually the, what is it, countertop cooler or not walk-in, reach-in cooler. It's usually there, but I never know someone actually use R290 because it's flammable. Highly flammable, as far as I've seen from YouTube.
And as you can see, my model is using the R290. And by the way, this is a very contaminating product that is damaging the ozone layer a lot.
Okay, no. Some refrigerant did destroy ozone and high GWP, like 410A have high GWP, while R22 have high ODP, is an ozone depletion. What's the P? Potential, yeah. But I believe R290 don't do that. Let's check it. What's the GWP of R290? It's a propane. It's a propane. And 404 and 404 is usually for a small refrigeration on low capacity. It doesn't say which 407 because 407A, I believe there is 407B, if I remember correctly, and then 407C is usable in AC. So I'm not surprised about that one. But this doesn't say which 404. What's the GWP of R290? Low GWP and zero ODP. So the refrigerant used here is not ozone depleting and have a small GWP compared to like 410A and R22, which is honestly, from experience, it works the best. And it survived most of the lack of maintenance, but yeah, things gotta change.
Anyway, when the pressure drops, the boiling point of the refrigerant also drops, and the liquid will turn into a gas. So that means that some energy was...
Okay, here's the thing. The liquid don't turn into gas inside the filter dryer. It does that inside the evaporator. That's why there's a thing called superheat. and it's a measurement done on the suction line and the pressure of the refrigerant. So where's his model? Where's his model for the evaporator? Let's see, where is it? Where's the model? No, I couldn't find it. Can I see it here?
Special liquid is not water. It's a special
let's see if I
substance
can pause
that
it
will
here.
boil at room temperature.
Oh no, too far. No, I can't do that here. Where is it? Where's other 3D model for the... Here it is. So typically, if you measure the suction temperature and the pressure, from what I heard, it's the same as you put a probe here. It's like in the middle. It's right in the position where you have half liquid and half gas refrigerant, and that's how you measure superheat. And that's also how you make sure all the liquid refrigerant boil off into gas, typically at the end of the evaporator, so it doesn't return to the compressor and cause damage. By the way, that's also what the suction accumulator is for. Not to remove hissing, and it's not a muffler. It's a suction accumulator.
Boil on the hot side.
What else? And he went ahead on explaining how TXV works and what it looks like. Though there's one other thing that actually triggers me here. Where is it? Which part is it? I believe it's somewhere when he opened it. I think it's here. Oh, here it is.
That stands out is this huge capacitor. This is actually a high voltage capacitor.
Excuse me? You tell me where's the high voltage, seriously.
Of only 25 microns.
Here it is. It's only rated 450. Typically operating at like, if I remember correctly, I measured it a while ago, it's like 370 on a 220 volts input, 370 to 380 at most, and nowhere near high voltage rating, because this is what high voltage is. It's above 1000 volts for AC and at least 1500 volts for DC. So I never seen any air conditioning system have high voltage in it. Okay, maybe the commercial one, but I don't work on commercial ones. But I don't see any high voltage here. Okay? There's no high voltage in this thing. Where is it? I think that's all I need to address. And he also talked about the inefficiency, which is also explained by technology connections, because how the system works, how it sucks the indoor air to cool the condenser. That is accurate. Yeah, I think that's all. If you want to go ahead and watch the full video, go ahead on this channel. The channel is called Electronoobs on YouTube. That's it. Thanks for watching, and I'll see you next time.